On the trail radio here, showing you the Baofeng UV5 series. Now this goes for the UV5R, UV5G, or any other Baofeng with the same code as the Baofeng UV5G. Now what we're looking at is option number 25, the shift direction. Now if you put a positive, negative, shift, then it will go up in frequency when you transmit or down in frequency whenever you transmit. Now the reason this is necessary is whenever you have an offset, that is what allows you to access repeaters. So let's say I was on GMRS 15 462.550, then I had an offset of 5 megahertz with a shift of positive. That means it will now transmit on 467.550, which is how you access repeaters. That is also how you access ham repeaters, but with different offsets. So, whenever you actually go through it, you'll see that the positive means it goes up in megahertz. So, 462.550. If I had a negative offset, what that would mean is it would go down in megahertz. It would be 457 instead of 467. If it's off, it means I am transmitting only on this frequency. I am simplexing. Very commonly, it is used with your offset. Now anything in the UHF, also with GMRS, is going to be a 5 megahertz offset in the positive direction, unless you're accessing a repeater from the repeater, which would have a negative 5 offset. Either way, it is necessary to have that offset along with your shift direction. In layman's terms, what it is, if you have a shift direction off, you are transmitting on the frequency shown. If you're in the positive shift direction, then you are transmitting above the frequency shown. If you're in a negative direction, you're transmitting the frequency below the shown frequency. For example, this is what it would look like. As you saw, this 2 turns into a 7 with the 5 megahertz shift direction. And what that does is allow you to access repeaters. That way you can talk not only 1 or 2 miles, you can now talk 50, 70, some odd miles.